Our first lesson with finances this year is about future value annuities. Now, if you listen to your mom and dad talking, they are talking about that they have to save for their olden days. And you save by using an annuity. These notes are everything on your notes on page 2. Page 1 is just a summary of all the formulas that we're going to use in grade 12. An annuity is a series of equal payments at regular intervals over a period. It's subject to an interest rate. So you regularly, monthly or yearly or quarterly deposit the same amount into a savings account. And you can have short-term or long-term annuities. Now the one that we're going to use or start with is our future value annuity. It means that we're going to save the same amount every month or every half year or every term for a period, the same amount for a long term of period. So, for instance, let's say you save 1,000 Rand every month up until when you are 60. And then you're going to use that amount for your olden age. Okay. So, future value annuities are capital that accumulates. This 1,000 Rand accumulates with compound interest, and you deposit equal payments. It's the same amount every time that you make a deposit. You can have a long-term annuity, future value, that's for retirement, or short-term when you save for, let's say, a holiday, or your parents saved for your university funds or whatever. The goal for a future value annuity is to save money for the future so that you can use it in the future. There are a couple of formulas that we're going to use. We start off with the future value formula. This is how it looks. Now just copy these, make sure these are correct on your notes. The F is the future value of your savings after a long period of time. The N, that is the exponent, is the number of payments. A hash in maths is number of. So how many payments are we going to make to get our future value? N is the number of payments. I is the interest rate. Now you take your interest and divide it by 100, but what comes with that is you multiply the denominator with the number of payments in a year. Not the total number of payments over the whole period, only the number of payments in 1 year. You also multiply that with the 100. And X are the equal payments that you pay monthly or quarterly or half yearly or whatever. Now let's do 2 examples. These examples are not on your notes, so you have to copy the questions. The first future payment that we're going to do is when you make payments at the end of the month. That's today's lesson. When you make payments, equal payments, every end of the month. Right, the first example is Jennifer decides to invest 600 Rand every month for 2 years in a savings account. The interest rate is 12% per annum, compounded monthly. She makes each payment at the end of the month. This sentence is important in a question. You have to know whether the payment was made at the end of the month or at the beginning of the month. Today's lesson is only about end of the month payments. What is the value of the investment after 2 years? Okay, I'll give you time to copy the question.
The test on the USD trade, how much of it?
I think it was 35 or 30. Can't remember the exact one. Are you all done? Alright, when you start doing financial questions, you read your question twice. The first time is just to get an overview of what is given and what's asked. The second time you read through your question, you start filling in these variables. Okay, so let's start. Jennifer decides to invest 600 Rand every month. What is that 600? F, N, I or X? X. Because she pays 600 every month. It's the same amount every period. For 2 years. So we get 600 every month for 2 years. What is the 2 years? N. But I must multiply it with how many payments are there in 1 year? 12. Then we read further. The interest rate is 12% per annum, compounded monthly. That is I. So it's 12 over 100, but 100 must be multiplied by how many payments in 1 year? 12. And what is the value of the investment after 2 years? So we have to calculate F. If you multiply this out, you will get an answer of 0,01. Now we go to the formula. And we substitute all the values. We want to work out F. X is 600, block bracket, round bracket. 1 plus I is 0,01 to the power of n is 24, minus 1 over I is 0,01. Now you use that key on your calculator with a block over a block to type this in, and your final answer will be in rand. Don't forget your rand sign. It is 16,184 rand and 8 cents. Any questions?
Then how is 0,088 cents?
How is 0,
Then how is 6,08?
8 cents?
How is that 8 cents?
That is the rand. Rand also always has two decimals, so it's 8 cents. 10 rand 99 is 10 rand 99 cents. So this is 8 cents. Do you have it? If you have 10 cents, it means it's 0 rand and 10 cents. And 8 cents will be 0 rand, 0 tenths, but 8 units. Okay. Let's look at our second example. Number 2. Quickly copy that question. Nico has just started his first job after completing his studies. He decides that he will take his first big holiday in 3 years' time. By then, the holiday will cost him 20,000 rand. How much should he pay into a savings account every month to have 20,000 rand in 3 years? The bank offers him an interest rate of 18% per annum, compounded monthly, and payments must be made at the end of every month. Are you done copying the question? Right, let's go through the question. Nico has just started his first job after completing his studies. He decides that he will take his first big holiday in 3 years' time. So there's our first variable. Where must I put 3 years' time? In. But it's 3 times. By then, the holiday will cost him 20,000 rand. Where do I put the 20,000? Future value, 20,000. How much should he pay into his savings account? What are they talking about here? X. So we need to work out X. Every month, so they give you the clue, every month, so I have to multiply with 12. And here I have to multiply with 12 in the denominator. To have 20,000 in 3 years. The bank offers him an interest rate of 18%. So it's 18 over 100 per annum, compounded monthly. The monthly is the times 12 and the times 12. 3 times 12 is 36. And if you calculate I, you will get 0,015. Now they want x. So I have to solve x first. Get x alone. You multiply with I. What you do on the right hand side, you must do on the left hand side. So these i's cancel out. Then to get x alone, I have to divide with the block bracket. What you do on the right hand side, you must also do on the left hand side. And then the block brackets cancel out. So we get x equals f times I over 1 plus I to the power of n minus 1. And now that you have solved x, you can substitute all the values. F is 20,000. I is 0,015 over bracket 1 plus I is 0,015, close the bracket, to the power of n 36 minus 1. Again, you use your block over block key on your calculator, and then you get the monthly payments. That's also in rand. Don't forget your rand, your units. And that equals to 423 rand 5 cents. So Nico has to pay this amount every month for 3 years to get 20,000 rand for his holiday. Any questions? Okay, now I want to ask you, how does this formula differ from the one that you learned last year? What's the difference?
We divided by I.
Yeah? we have monthly payments. Here we had a once-off payment and it stayed in the bank for a number of years or months. Now we deposit every month the same amount, so it grows exponentially, compounded. Alright, so that's the difference. Your homework for tomorrow are the questions on page 100 in the textbook. Number 2, 4, 7 and 10.